We're going to move forward here and talk a little bit more about quadratic equations, quadratic functions. Now, what we have to get into a little bit is what do we do if we're going to try to solve something where we can't factor it. Alright, so we spend a lot of time, or quite a bit of time, talking about how you factor something and then how you use factoring to solve something. So now what we're going to do is we're going to get into starting to discuss some of the various methods that you can use to solve quadratic equations or even rewrite quadratic functions that don't involve factoring. Okay, so what we're going to talk about today is a method called completing the square. And before we even complete the square, we're going to talk about how in certain cases we can use just square roots to solve quadratic equations. And then when we get into the completing the square process, basically what we're looking at is I'm going to create one of those perfect square trinomials, or basically something that can be factored and then written as a square of a binomial. So that way I can go ahead and move forward and solve the quadratic equation. So basically what we're looking at here is when we're completing the square, we're trying to get one side of the equation to actually be factorable. So I can write in something in general like this and then just have a number on the other side. Because moving forward, what I can do with that then is I can use a square root to kind of move forward and solve both sides. Because the whole idea on the left side is a square root will cancel out this power of 2. So I will just be left with x plus 2 and the square root of 6 on the other side. And I can solve and get some type of solution. But we'll get a little bit more into that as we move forward here. Now, completing the square, that's going to be a term that you hear me refer to quite frequently as we move through this lesson. All right, so you'll get a little bit more accustomed to what that means here as we go forward. All right, now really all we're talking about right here is the simple fact that factoring is probably your best bet as far as trying to solve a quadratic function, but there's going to be certain situations where something might not easily be factored, or in certain cases you're not going to be able to factor it at all. So you need to have other alternative methods in place that you can use if factoring is not going to be an option for us. Okay, so basically what we're going to start with is in certain cases when quadratic functions or quadratic equations are missing that middle x term, when we think about writing things ax squared plus bx plus c in standard form, if this term is missing, all right, what we can do is we can just use square roots to solve a particular function or a particular equation. All right, so we don't have to worry about factoring. We don't even have to worry about completing the square yet. We can just use square roots all by themselves. Now the key is, normally when you take the square root of something, we just say the square root of 4, we usually just write 2. All right, now that's not wrong, but we've also talked about the fact that negative 2 can actually be a possible answer to that. So keeping in mind that you can actually have 2 answers when you take the square root of something, what you need to do is, if you're using square roots as a means to solve a problem, you need to make sure that you write plus or minus in front of whatever number you would get when you take the square root of it. And you'll see that in action here a little bit as we go. Alright, so this is the first type of quadratic equation that we're going to talk about. Now what you will notice is we have an x squared term and we have constants, but we don't have an x term. Alright, because we don't have an x term, we think about things a little bit differently. Okay, normally if we were trying to factor, we would move everything over to the left side and we would set it equal to 0, and we would go from there trying to figure out what can we take out of it, or can we factor. Well, in this case, because we don't have that x term, I'm actually going to subtract the 11 over to the other side. Alright, so 4x squared is going to equal 48. Alright, I want to get this x squared by itself, so I'm going to divide by 4. So x squared is going to equal 12. Okay, now that I have the x squared all by itself, I can use a square root to actually get the x by itself. And on the other side, for right now, we would say I have plus or minus 12. Now, I know you've worked with square roots before in Algebra 1. We touched on them a little bit here at the beginning of the year. What I have to look at is I can't leave something as the square root of 12 if it's possible to break it down any further. So what I'm looking at is, are there perfect squares that go into the square root of 12? And the answer to that is yes. I can think about this as the square root of 4 times 3, or the square root of 4 times the square root of 3 if you remember your square root properties. Now, we all know the square root of 4 happens to be 2. I can't do anything with the square root of 3, so I leave it like that, and I put a plus or minus in front of it to signify that I can have the positive or negative version of that answer as a solution to this particular problem. Now, typically, the biggest issues I have with these problems are, 1, people want to write decimals. We can't write decimals. We need exact answers. So your answers, unless it comes out to be you have something that's a perfect square, where you can just take the square root of it and get a whole number or an integer, you have to leave the square root in your problem. So the biggest issue after that becomes breaking down square roots, thinking about perfect squares that go into something so I can simplify and write things in their reduced form. Alright, now we're going to look at something like this, and you'll already notice we have that x term in there. So I can't just use square roots to solve this. But what this problem is going to do is it's going to lead us into a little bit better idea of how we're going to complete the square. Now, last section we talked about a difference of squares, and we also talked about a perfect square trinomial. Alright, what you will notice on this side over here is I already have a perfect square trinomial. Now, if you don't know that or don't recognize it, don't freak out, because most problems aren't going to be set up this way to begin with. Okay, but I'm just going to look at this without doing anything with the 28 over here. I'm just going to leave that there. I'm going to see if I can go ahead and factor what's on the left side here. And like I told you, I already know that I can. All right, I'm going to get x and x plus and plus 6 and 6. All right. Now, I knew that because I'm used to looking at that. You're going to have a couple of problems that are going to be set up like that already, where the entire left side is already going to be factorable. And it's one of those special situations where I really only want to factor that as is, because it allows me to write it as a square of a binomial. And what that does for me now is I have an entire quantity squared. So I can go ahead and square root it at this point. So x plus 6 is going to equal plus or minus the square root of 28. Okay, so the squared part was kind of the furthest out operation there. I couldn't do anything inside of here, and I can't subtract that 6 because it's being squared on the outside. So my next step is to take the square root of what's going on there. Now, I know I'm probably going to be able to break down the square root of 28, but before I do that, I want to get x all by itself. Alright, so x in this case is actually going to equal negative 6 plus or minus the square root of 28. Now, I'm going to rewrite it up over here to the right. And the reason I'm going to do that is because I'm going to have to take a look at that square root of 28. And perfect squares that would go in there would be 4 and 7. Okay, well, 4 being the perfect square, 7 just being the other number I would have to multiply by. So if I'm going to simplify things a little bit here, I'm going to end up with negative 6 plus or minus 2 square root of 7. Okay, and just remember this part up here, this is just a matter of square root properties. Technically, we start breaking things down like this, and then we can rewrite them underneath the same root, and eventually work down to our simplified answer. Now again, we don't want decimals. We can't combine this negative 6 with this over here because one part has a radical and the other part does not. So that's as far as we can go. We have to leave things as is. like that, and this down here would be your solution. And again, the whole idea is because of this plus or minus in here, it still represents two different answers. All right, and like when we were talking about factoring, this answer right here represents the x value or the x values as to where your parabola would intersect the x-axis. The only thing different in this particular case is it's not going to be a whole number or an integer, okay, just like +2, -2. You actually are going to have some type of decimal if you were to carry it all the way out. So that's why we leave them in radical terms, all right, because it's more of an exact answer. All right, I want you to go ahead, pause your video, give this one a try on your own, come back, and we'll see, if you're making progress in the right direction. All right, so again, the first thing you want to point out, or the first thing you want to realize about this particular equation is the fact that there's no x term. All right, if there's no x term, I'm not going to try to factor. I'm not going to try to complete the square, anything of that nature. Okay, I'm just going to go ahead and add the 20. Oh, 20, not 28. Over to the other side. All right, so I'm going to get something that looks like this. Okay, again, there's no x term. I'm going to use square roots to solve this eventually. Now, I still have to get rid of this 4, all right, because I want to get the squared term, whatever squared, completely by itself. So I'm going to end up with x squared equals 25 over 4. Again, leave it like that. Don't try to make it a decimal or a mixed number because it's not going to help us out at all. All right, to solve x, I square root both sides, which basically means what I am doing is I am taking the square root of the top and the square root of the bottom. So the square root of 25 is just 5. The square root of 4 is 2. All right, so essentially I get plus or minus 2.5 as my answer. Okay, again, those should be relatively easy because you don't have an x term. We really haven't got into how to officially complete the square, just kind of something similar to what it's going to look like. But those should be relatively easy. All right, here's another one. Pause your video. This would be like the second example that I went through. Take a look at it, see what you can come up with, and come back and we'll check the answer together. All right, now this, like I said before, is similar to the second example. I'm not going to do anything with this 49 right now. I'm just going to leave it there because I can already tell that this is one of those perfect square trinomials. Okay, or basically what you're looking at is half of this number squared is giving you that right there. Okay, so I know this is going to end up as x plus 4 and x plus 4 equals 49. So basically what this allows me to do is write it, my factored part, as a square of a binomial. All right, so now the squared term is essentially this whole thing that's in parentheses. So I want to go ahead and square root both sides. All right, so what's going to happen is I'm going to get x plus 4 equals plus or minus, in this case, the square root of 49 actually gives me 7, which is kind of nice to have a whole number. We don't have to worry about a radical in this. All right, my last step would be to get the x completely by itself, so I have to subtract 4 over to the other side. So x is going to equal -4 plus or minus 7. All right, now because there's no radical here, I am not done. Okay, because I have two integers, -4 and 7, well actually plus or minus 7, I have to go ahead and combine those. So I'm actually going to get two integer answers here. -4 plus 7 is going to give me 3. -4 minus 7 is going to give me -11. All right, two answers, and again, I can actually work all the way out to those two answers because I don't have radicals involved in this aspect of my answer over there. Okay, so again, two answers. Basically, if you were to go take and fill those back into the original, it would make that statement true. And in terms of a graph, if we were to graph the parabola, okay, or basically if we were to subtract this over, simplify, and then graph that parabola, you would end up with these 2 points right here as the points on the x-axis where they intersect. Now the other thing to think about here is, say you would just graph this and then graph this separately as a horizontal line. these two solutions right here would represent the point at which your parabola actually intersects that horizontal line. All right, so if it's not set equal to 0, we're not looking at where it's crossing the x-axis. In this case, it's set equal to 49. So this would be the line y equals 49, and this would be my parabola, which would be x squared plus 8x plus 16. All right, in this case, these dots right here are still -3 and -11, but we're not crossing the x-axis. We're crossing the horizontal line that is y equals positive 49. If we were to have subtracted the 49 back over there and set it equal to 0, then these points down here would represent where I'm crossing the x-axis, just like before. So same idea, but it's a little different if it's set equal to 0 as opposed to set equal to some other number. All right, now we're going to get into how we actually complete the square. And like I said before, basically we were kind of doing this already, but it was already set up for us. What we're going to have to do now is we're going to have to show, or basically figure out, how I start with something kind of similar to this and how I get that extra term in there that makes something be factorable as a square of a binomial. All right, now the overall process really isn't that difficult, but you have to keep in mind and think about what you have to do each time. All right, and I know this is something that is on your note guide, so you should probably take it down just to make sure that you understand what's going on here. Now this next slide, I was kind of debating on whether to include it or whether not to include it. A lot of people tend to ask the question, what is it? Why do they call it completing the square? Well, basically, if you think about tiles, algebra tiles, I don't know if you used these when you were younger or not, but we can use a larger tile to represent x squared. We can use smaller tiles to represent all the x terms, and then we can use even smaller tiles to represent our constants or our just simple basic number terms. All right, and what we're doing here is we're starting with something that looks like this, and we're trying to figure out what that last number has to be in order to make it a perfect square trinomial, or something that can be factored as a square of a binomial. But at the same time, we're almost trying to complete this bottom corner here, which in a sense completes the square. Okay, so that kind of has to do with the whole idea behind why we call it completing the square. So what we're going to start with here is we're just going to talk about what you have to do in order to make this whole expression something that can be factored as a binomial square, okay, or something where we can write a quantity squared. So what I'm looking at here is, in order to get this last term, I take and look at this number right here. And it really doesn't matter whether it's positive or negative, but we'll think about it from that aspect right now. So what I want to do is think about what is half of -14, which would be -7, and then I square that number. All right, which is going to give me 49. 49 represents the number that goes in there. Okay, so when it's all said and done, x squared minus 14x plus 49 would be something that I could factor, and basically it's going to give me x minus 7, x minus 7, which I can write as x minus 7 squared. Okay, so again, half of this number and then square it. That would be the number that goes at the end of it. Okay, and then basically whatever half of your number was, which in this case was -7, that would be the number that goes into each parenthesis when you're factoring. Or if you want to go straight to writing it as the square of a binomial, it would be the number that fits in there with x in your squared binomial. Okay, again, we're going to take a look at another one. Now what you'll notice here is, not only is it positive, which again doesn't matter because you're going to square half of that number anyway, okay, but it's also an odd number. So when we take half of 9, we're just going to write it as 9 over 2. Okay, or basically we're taking that b term and we're dividing it by 2, which is the way that the technical definition looks like. So 9 over 2, and then I'm going to square that. So basically I end up squaring the top and the bottom. So I get 81 over 4. 81 over 4 is the number that's supposed to go in there. If I were to factor this and write it as a square of a binomial, I take basically half of whatever that original b term was, and that's what goes in the sets of parentheses. Okay, so again, if you have an odd number here, you're going to get a fraction down here. Don't write it as a mixed number. Do not write it as a decimal, because it's not going to work out. We don't want decimals. We don't want mixed numbers, especially when at some point we're going to have to take the square root of things. Alright, so take a look at this one. Try it on your own. All you're really looking for is the number that goes in here. You don't have to factor anything right now. Just figure out what number goes in there. So pause your video. Come back when you're done. Alright, quite simply, we're going to take this b term, which is 4. We divide it by 2. We get 2. So the number that should go in this box right here is 2. Alright, so it looks something like this. Alright, and technically if I wanted to factor it, I would go x plus 2 squared. You know, I could write it twice, but after a while you just kind of start to get the idea that as long as you know that in this case both of our signs are going to be positive, whatever half of this is, which we said was 2, is going to be the number that goes in your factored expression. Okay? Oh, excuse me, I wrote that wrong. Half of it is 2. We have to square it when we put it here. That's my fault. I'm sorry. Plus 4 should be over there. Got moving a little quick there and kind of lost track of what I was doing. Okay, so again, half of b, which we did right here, is 2. 2 squared gives me the 4 that should go up over there. Okay, so sorry I wasn't trying to confuse you there. And then when you factor things out, whatever half of this number was, all right, half of that number, all right, is what goes in when you have your factored expression. All right, let's look at this one here. Okay, same idea. Pause your video, come back. All right, we'll talk about what you came up with. All right, now again, you can see right away, odd number. So when I take half of it, I'm just going to put it basically over 2. All right, then I'm going to square it. I'm going to get 9 over 4. Okay, so 9 over 4 is the number that goes right there, that finishes or completes my square. All right, if I were to factor this, x plus whatever half of my b term is would be the thing that's in the square of my binomial. Okay, so hopefully you get the general idea how this is going to work. All right, now eventually we're going to apply this to actual problems, and hopefully if you understand how to make this work, it'll make things a lot easier in the long run. So we're kind of piecing things together as we move forward here. All right, now I want you to make note of this particular slide. This is very important because this basically walks you through step by step what you are supposed to do if you are trying to solve something by completing the square. All right, simple step-by-step procedure. If you follow it, you're not going to get the process wrong. All right, from there on we just have to focus on our algebra a little bit as far as square roots, squaring things, and fractions. All right, so now an actual equation where we're going to try to complete the square. Now, eventually what's going to happen is we're going to mix all these different types of problems together, and you're going to have to figure out on your own what the best method for solving them would be. So originally, what I usually like to do is, if at any time you can factor something, you want to try to factor something. So in the grand scheme of things here, what you would probably do is you would probably take these two terms, move them over, set it equal to 0, and try to factor. All right? But in this case, because we're talking specifically about completing the square, I'm not going to do that. Okay? I want to focus more on us understanding how to complete the square, not how to factor. But again, factoring is always your best bet if you can do it. All right? So anytime you try to solve something and you aren't told originally what method to use, always try to factor something first. Okay? Well, in this case, I'm not going to factor, so what I'm going to do is I'm just going to subtract the 12x over. And I'm going to leave the negative 20 on the other side. Okay, so the whole idea is I want to take this right here, and I want to be able to write it as a square of a binomial. So actually what I'm going to do is I'm going to write the same thing, but I'm going to leave myself a space, because essentially we're going to fill a number in here. So this goes back to what we just talked about. We take half of that b term, which would be negative 6. We square negative 6, and we get plus 36, positive 36. Now, before, we didn't have equal signs or anything of that nature. So we just went ahead and we, factored this side over here as a square of a binomial. All right? But because it's an actual equation, we have to keep things balanced. So what we're going to do is, if we add 36 to this side right here, we have to add the exact same thing to the other side of the equation. All right? Because again, I can do whatever I want to one side of the equation as long as I do the exact same thing to the other side. So if I bring in a 36 kind of randomly over here, I have to do the same thing over here. Now the whole idea is over here, this side should now factor as a square of a binomial. Or basically, it would end up being x minus 6 and x minus 6. Okay? But I want to write it like the square of a binomial. On this side over here, I'm going to get 16 when I combine those terms. Alright, so let's rewrite up here real quick. I have x minus 6 squared equals 16. Alright, now we're back to the type of problem that we originally started with at the very beginning of the lesson. I'm going to square root both sides to get rid of that squared term. So x minus 6 equals plus or minus 4. Alright, I'm going to go ahead and add the 6. So x equals 6 plus or minus 4, and I go ahead and I want to perform that calculation or those calculations. So we'll go 6 minus 4 is going to be 2. 6 plus 4 is 10. Alright, now again, basically what we're looking at here is 2 and 10 are the solutions to this quadratic equation. We just have to think about it in kind of perspective here. If we look at what's going on in this section right here, I have x squared minus 12x plus 36, and essentially it's equal to 16 on that side. So we think about the graph of this. If we were to graph this side, it would intersect the horizontal line of 16 at these points. Now, had I actually taken the 16 and moved it over and subtracted it, all right, I would have ended up with these two values down here representing the x values where my graph would cross the x-axis. So it just kind of depends. If it's set equal to 0, these represent where your parabola would cross the x-axis. If it's set equal to some other number, like in this case 16, these numbers down here represent where the parabola would intersect the horizontal line at 16. Same general idea again, but we're just looking at things in a little bit of a different context. Alright, now another example. And this one's a little bit different, so I'm going to kind of rearrange things a little bit. We already have our constant term on the right, so we're going to leave it there. But I want to make sure I write my squared term first and my x term second. Now, you cannot complete the square if you have a number in front of the x squared. So what I'm looking at here is I'm going to factor it out, and I'm really only looking at these two terms here. I do not care about this 45 right now. Alright? They're both divisible by 3. Okay? And technically they're both divisible by 3x, but I'm just going to take out a 3 for right now. Alright, so if I take out a 3, that leaves me with x squared plus 6x. I'm going to leave a little room there and put 45. Okay, now I can actually complete the square. So half of 6 is 3. 3 squared is 9. So I'm going to put a plus 9 here. Now, this is where the most commonly made mistake happens with this particular type of problem. I can't forget about this 3 out front. Before, on the previous problem, I added 36, so I added 36 to the other side. Well, here, I bring in a plus 9, but technically I have to remember that that should be multiplied by 3. So really what I brought in is a plus 27. So that's why I have to put a plus 27 on the other side. All right, now the whole key there is, okay, just keeping things balanced. You only have to think in terms of that if you pull a number out to begin with. All right, so I'm going to leave the 3 there. This should now factor as x plus 3 squared. Okay, remember, x plus half of whatever this number is in here. Okay, on the other side, we're going to have to go ahead and figure out 45 plus 27 is going to equal 72. Okay, now I'm essentially to the same point I was before, but what I need to do before I square root is I need to divide by 3. Alright, I'm going to rewrite up here. I have x plus 3 squared is going to equal 72 divided by 3, which is 24. Alright, now I have the squared portion of the problem by itself, so I can go ahead and square root both sides. So x plus 3 equals plus or minus the square root of 24. Alright, now again, I know I'm going to be able to do something with the square root of 24, but I'm going to wait. So I'm going to just subtract 3 here. So x is going to equal negative 3 plus or minus the square root of 24. Now, perfect squares that go into 24. I'm looking at 2 would go in, or excuse me, 2 is not a perfect square. 4 would go in there. Alright, so I'm going to think about this as the square root of 4 times the square root of 6, because 6 times 4 would give me 24. So x equals negative 3 plus or minus the square root of 4 is 2. I can't do anything with the square root of 6, so I leave it as is. And that is my answer. I cannot go any further because I have a radical in there. Now, let's recap here for a second. Okay, going back to the beginning, I can't complete the square right off the bat because I have that 3 in front of my squared term. So what I want to do is I want to focus on the squared term and the x term. What do they have in common that I can take out as far as a number is concerned? All right, if we were normally just factoring, we would probably try to take out an x along with that 3. But because we're completing the square, we only take out the 3, which left us with x plus 6x, or excuse me, x squared plus 6x. Then I go through the process of completing the square just like I did before. All right, half of 6 is 3. 3 squared gives me the 9 that you see right here. Now normally, if I was just completing the square regularly, I would go ahead and I add a 9 on the left, so I'd add it on the right. But because you have this 3 term out front, really you brought in a plus 27. Okay, so that's why we added 27 to the other side as well, not just 9. From there, the problem becomes very similar to what we've done on previous slides. All right, why don't you go ahead and pause, give this one a try, see what you come up with, and then come back and we'll go through the answer. All right, now a little bit different start here. All right, in the previous couple problems, the x squared and the x have pretty much been on the left side already, and the constant on the right. Well, it's not in this case. So again, you should be looking at that, the notes from that slide, which give you the step-by-step process of what's going on here. But what I'm going to do is I'm actually going to subtract that 9x back over to the left, and at the same time, I'm going to add that 2 back over. So subtracted 9x, added 2, okay, to both sides. All right, now to complete the square, half of this number would basically be negative 9 over 2. We square it, we're going to get 81 over 4. Square the top and the bottom. Now in this case, we didn't pull anything out to begin with, so I'm just going to add 81 over 4 to the other side as well to keep things balanced. Now, there's a fraction there, but again, don't freak out. X minus basically whatever half of our b was goes in there. On the other side, okay, because we're going to have to be using square roots and stuff to solve here, what I want to focus on is keeping things written as fractions. So I'm going to write 2 as 8 over 4, just to get them common denominators. So if I take 8 over 4 plus 81 over 4, I am going to get 89 over 4 on this side. Okay. Now, again, leave them as fractions. It actually makes things easier in the long run. Okay. Now, square root your squared terms. All right. So that leaves me with x minus 9 over 2. On the other side, I want to look at, I would take the square root of the top and the bottom. Well, I can't take the square root of 89, but I can take the square root of 4. So I'd write the other side like this. Okay. Last step would be to go ahead and add 9 over 2 to the other side. So what happens is I get x squared equals 9 over 2 plus or minus the square root of 89 over 2. All right, now I want to look at that square root of 89 to see if there would be any perfect squares that go into it. Okay, 89 is a prime number, so nothing goes into it that's a perfect square, so I can't do anything with that. But what I can notice here is I do have common denominators, so I can actually write this as one fraction. Now you don't have to do that. If you would have stopped up here, that would be okay. In some cases, just when you check your answers from time to time, they might combine them and write them as one fraction. So I just don't want you to be confused if you see an answer written like this. If you wrote your answer like that, they mean the exact same thing. All right, they're just combined on the bottom because they happen to have the same denominator. All right, next one here I want you to go through on your own, and what you'll notice here is you have a number in front of the x squared, so you're probably going to have to pull out a number to begin with. All right, so pause it, give it a try, come back when you're done. All right, now this is pretty much set up for me already. I have my x squared and my x on the left side of my equation. All my constant terms are on the right. So what I'm going to look at here first is this and this have a 3 in common. So I'm going to take out a 3, leaving with x squared minus 8x. I'm going to leave a space, and that equals 27. Now again, had we been just factoring this part, we probably would have taken out an x with that, but in this case it doesn't help us because we're not trying to really factor the problem. We're just trying to make the left side of this factorable in a specific way. All right, so what I'm going to do is take half of negative 8, which is negative 4, square it. I'm going to get plus 16. Okay, now because that 3 is out front, not only have I brought a plus 16 in there, I have to multiply it by 3. So technically I brought a plus 48 in on the left side of that equation. So I'm going to add 48 to the other side to keep things balanced. Whatever you do to one side, you have to do to the other. Now, this should factor as x and then whatever half of this number was, so minus 4 squared. And you can kind of check that too. Think about my signs are supposed to be the same and they're both supposed to be negative. So if this is squared down here, that means I have that same set of parentheses written twice. All right, so they'd have to have a minus in both of them. On the other side, we got to think about what 27 plus 48 is. It'd be 75. All right, which 75 is a pretty good number to have there because my next step would be divide by 3 to get the squared term by itself. So x minus 4 squared is going to equal 25. Okay, squared term is by itself, so we square root it. X minus 4 equals plus or minus 5. All right, my next step would be to add, whoops, oop, didn't want to do that. Hang on a second. Let's get back to my, see if I can get back to my pen here. All right, sorry about that. All right, get back to my pen here. What I'm going to want to do is I'm going to want to add that 4 over to the other side. So I'm going to end up with x equals 4 plus or minus 5. So again, my two answers are going to be x minus 4, which is negative 1, and 4 minus 5, which is negative 1, and 4 plus 5, which is 9. Okay, So again, those are my two answers to that particular solution. Okay. Now, last thing we have to talk about here is basically how can we go from something that's in standard form and get it back to vertex form. We've already talked about how to get from vertex form to standard form, and we basically just do that by taking something that looks like this, foiling this area, distributing, combining like terms, and I get something that is in this form or standard form. Okay. Now what we want to do is we want to start with something that looks like this, and we want to work backwards to vertex form. Now that can only be done by completing the square. All right. Now the part about this is going to be a little bit different is it's not an actual equation, so it's not set equal to anything. All right. We have f of x. All right. And what I'm going to do is I'm not going to add or subtract anything to the other side, because in this case there is no other side. All right, we're representing a function that's set equal to, basically it's set equal to y, okay, or the f of x on this side. So I have to do everything on one side of the equation this time. So I'm actually going to leave my space like this. So I'm going to complete the square just like I did before. Half of 16 is 4. 4 squared is 16. All right, now before, when I brought a 16 in on one side, I added the same thing to the other side. Well, in this case, everything's on the same side. And I did that wrong. Sorry. Half of 16 is 8. Let me get my eraser up here. Half of 16 is 8, and 8 squared is 64. I apologize for that. All right. So, we got to make sure we get the right numbers first. Okay, so half of 16 is 8. 8 squared is 64. All right. Now, like I was saying before, because everything's on the same side, and this is going to look goofy to begin with, but we actually subtract 64 on the same side. So when you add 64 and subtract 64, really you haven't changed anything. All right. Now, this part here should be factorable. So I have f of x, and that's going to equal x plus 8, or basically x and half of whatever this term was right here, is going to equal negative 76. Okay, and it's not going to equal negative 76. Okay, you're just going to have negative 76 on that side. Okay, so again, as I'm talking through this, you can kind of see how, like, even I'm making a couple little bit of mistakes here as far as talking about what you're supposed to do, just because it is different from what we did before. All right, so again, you think about this stuff over here separate. All right, it's on the same side, but it's separate. All right, so basically, this is my answer. I don't have to go any further. I don't have to solve anything. I just want to know what it looks like in vertex form. All right, and the vertex in this case would be negative 8, negative 76. All right, so relatively large. All right, but really, you know, we just did something a little bit different and kind of worked backwards to get from standard form to vertex form. So here's another example. I'm going to run through this one, and what you'll notice is we have that number right there. Okay, so what I need to do here is the same general idea as what I did before. I'm going to split things up a little bit before I go any further. Plus 7 back there. Okay, the first thing I want to do here is I want to take out a 3 of those first two terms. All right, and again, I'm only worried about the first two terms because I'm just trying to make that part factorable. So I still have my plus 7 back here. All right, so half of 6, negative 6, excuse me, half of negative 6 is negative 3. Negative 3 squared is plus 9. Okay, again, you have to think about this the same way we did before. I didn't just bring in a plus 9, I brought in a plus 27. So I have to subtract 27 over here. All right, so now this part in here factors as x and half of whatever the b term was squared, and it's going to be minus 20 when I go ahead and combine this stuff over here. All right, so this represents my vertex form. In this case, my vertex is 3, negative 20. Okay, so after you get used to working with everything on one side, it does become a little bit easier because you don't have to go ahead and solve anything. You just kind of have to write everything expressed out the way that you think it's supposed to look. All right. So for the sake of time here, I'm not going to worry so much about this one, but I do want you to give this one a try because it's a little bit more on the difficult end, because you're going to have to do something with this 5 to start with. All right. So go ahead, pause it. Last problem, give it a try. Come back and we'll kind of see where we're at with this. All right. So first thing I want to do is I'm actually going to kind of do this in 2 steps. I'm going to take a 5 out of both of these terms. All right, so 5, I'm going to have x squared minus 10x. I'm going to leave some room, and I have plus 128 over here. All right, we'll complete the square with the portion that's in parentheses. So half of negative 10 is negative 5. Negative 5 squared is plus 25. All right, now again, I didn't just add 25. Technically, I added 125. So I'm going to subtract 125 from that same side. All right, now I'm really only about a step away here. I write this as a square of a binomial, and I have a plus 3 on the end. All right, so my vertex is 5, 3. Okay, now again, hopefully we were kind of able to work through all this stuff. You might not have known 100% how to do everything from the very beginning, but as we work through this, hopefully you should have a pretty good idea as to how you can complete the square to solve in a quadratic equation, or you can use completing the square to take something that is in standard form, like we had in this particular case, and write it in vertex form. All right? So if you have questions as you're going through this, please make sure you make an effort to come in and ask. All right? You should have your note guide completed, and also you should be able to get a start on your homework for this week. Don't save it all for class, and don't come in and say, oh, I don't know how to do anything. Okay, use your notes. All right, try to put things together. Your homework is going to start out relatively simple. It's going to piece things together like we did for the first few examples, okay, before you even get into having to solve something by completing the square on your own. All right, so that's all I have for you. Make sure, like I said, to get a jump start on your homework so you're ready to go when you come to class.